Okay, so now we're going to start working a lot more with algebra proper. And in order to do that, we're going to deal with properties. Commutative, associative, and identity property are the first we're going to work with. And in class, I'll give you a story that'll help you tell the difference between these. But the truth is, you really just have to memorize them. It's one of the few times in your life that I'm going to tell you to flat out memorize something. But you're not really going to have a choice. It's the only way to remember. All right, so the commutative property says that regardless of what order you add two things together, you're going to get the same answer. So 2 plus 3 is the same as 3 plus 2. That makes sense. 2 plus 3 is 5. 3 plus 2 is 5. Commutative property of addition says that it doesn't matter what order you add two numbers together, you're going to get the same value. Same thing with multiplication. A times B is the same thing as B times A. 2 times 3 is the same thing as 3 times 2. 2 times 3 is 6. 3 times 2 is also 6. Commutative property says that you can move numbers back and forth around an operation, this case addition, in this case multiplication, and you're going to get the same value. Now notice this is the commutative property of addition and multiplication. I'm not saying anything about subtraction and division. I am only saying addition and multiplication. Okay, the associative property, what does it say? Well, it says that if you have more than two things that are being added together, the order of operations, you know, tells you to add A plus B together first and then add C. But the associative property says that you have a little bit more freedom than that you can, if you have three things added together, you can choose to add B plus C together first and then add A to them. So it doesn't matter when they're all addition, it doesn't really matter which two you add together first and then add the third, you're going to get the same value. And that makes kind of sense too. 1 plus 2 plus 3, 1 plus 2 is 3 plus 3 is 6, or 1 plus 2 plus 3, 2 plus 3 is 5, plus 1, 6. Same thing is true with multiplication. A times B times C. Order of operation says you have to do A times B first, but the associative property says that in this special case, it's okay to multiply B times C first and then multiply in A. And the identity properties say that for addition, there's something that you can add to any number and you get the same number back. So if I have some number A and I add 0, I just get A right back. 0 is the identity element, and this is the identity property of addition. And for multiplication, there is something that you can multiply to A so that you get A back. And of course, that's a 1. A times 1 gives you A. 1 is the element, so let's write that down. Identity element. And in addition, the identity element is 0, and in multiplication, the identity element is 1. All right, so first we're going to look at a problem that uses addition, and we're going to use these identities. Maybe all of them, maybe only one of them. So suppose I'm asked to add 2 plus x plus 3 together. When I look at this, order of operations says that I have to do 2 plus x. That's order of operations, right? Well, I can't combine 2 plus x. I don't even know what x is, so I can't add it to 2. I'm kind of stuck. But I could add 3 to 2, but the question is, am I allowed to do that? Well, I actually can, because I can switch to, whoops, that's not switching. I can switch x plus 2. I can rotate them around each other, right? So now all I've done is reverse them. And what operation tells me that I can switch them back and forth? That's commutative property. So the commutative property of addition tells me that it's okay to switch these back and forth. But it didn't matter that I switched it. Order of operations says that I have to add what's inside the grouping symbol. But remember, I put those grouping symbols in, right? So I can take them out. This time I'm going to now write x plus 2 plus 3, and I'm going to move the grouping symbols away from the x plus 2, and I'm going to add the 2 plus 3 first. And that is the associative property of addition. And now I can do something with this. I have x plus, well, 2 plus 3 is 5. And now I'm down to an expression that I can't combine because x, I don't know what x is, so I can't add it to 5 yet. But I have certainly simplified this process. I've taken something that had 3 values, 2 were integers and 1 was a variable, and reduced it to something with only 2 values in it. Well, let's check one out that's like this one, only uses multiplication, and I'll use the same values. 2 times x times 3. 2 times x times 3. Well, order of operations says that I have to do 2 times x first. But commutative property of addition says that commutative property of multiplication says that I can switch those two values up. So I can put x times 2. Right? That's this one, the commutative property of multiplication, times 3. And now I can use the associative property of addition or multiplication. Addition on this side, multiplication on this side. And I can switch my parentheses so I group my two integers together. So I have x times 2 times 3. And now I can simplify this. 2 times 3 is 6. Times x, and in fact I can do one more application of the commutative property. Let's get the colors right. Of the commutative property, and I can write my final answer as 6x. So some of this work you've already been doing because it seems natural and true. Algebra is about doing something for a reason, not just doing it because you've been taught to do it or trained to do it. Algebra is about understanding what you're doing every step of the way and being able to do the same thing when numbers get much more complicated. So you have to know what the properties are rather than just rely on your instinct to reduce or solve algebraic expressions or equations. Okay, so now let's identify the property that's being used. So for the first one, I want to look at 3a plus 0 equals 3a. 3 times a plus 0 equals 3 times a. Okay, well, I haven't used a property to switch a and 3, right? I have not used the commutative property because 3a on one side is the same as 3a on the other side. And I clearly haven't used the associative property because I haven't grouped anything together. But I have added 0 so that I end up with exactly the same thing on the other side. So this is the addition property. This is the identity property. And it's of addition because the identity element is 0. Okay, another example. Let's identify the property 7 times s times t equals 7 times s times t. All right, so it's all multiplication. So now I know the property is going to be of multiplication. But which property? Well, 7st, they're all in the same order, so it's not commutative property, but the parentheses have moved, so it's the associative property of multiplication. Let's do another example. Negative 19 times 1 equals negative 19. Okay, well, what do we have here? It's obviously of multiplication, whatever it is. And which property? Well, I've lost the 1. That's all that's disappeared. But look at what I've done. I've multiplied a number times something that the same number comes back out. So that's the identity property of multiplication. Another example. 5 plus negative 12 equals negative 12 plus 5. Okay, so this one's a little bit tricky because it only has 2 values in it, but it also has parentheses. But notice these parentheses are just protecting the plus minus here. They're not actually telling you to multiply or to add 2 things together. So in this case, the parentheses have nothing to do with the property, but 5 and 12 have been reversed in order. 5 plus negative 12 plus 5. So the one that reverses the order is commutative. And since I know I'm dealing with of addition, and don't be thrown because this is a negative integer, I'm adding the negative integer. So it's of addition, and it's the commutative property because they switched the order. So the commutative property of addition. So there you go. We have 3 new properties to work with in algebra. We use those properties to evaluate expressions and later to evaluate equations. And we learn to identify the properties based on given information. This is where it's going to be the trickiest for you to use. I'll be asking you in future DRQs and tests to identify the property, and you need to be able to look at an example and tell me which property you've used. This part is a little bit instinctive. You've been doing it a lot of this all along, but I'll also be asking you to identify the property, and you need to know the properties. The only way, sadly, for you to learn these properties is to memorize them.